So we have a function f of x that is the product of two functions, g of x times h of x. And the product rule for differentiation says to find the derivative of this function f, here's what you can do. You actually can take the derivative of these each separately, okay? So let's say we take the derivative of g, but then you have to multiply it by the original function h. Not the derivative of h, but the original function h. And then you do the same thing with the h. You can take the derivative of h and multiply it by the original function g and add those together. And that will produce the correct derivative. Okay? So you do the derivative of one function, multiply it by the other original function, plus the derivative of the other function times the original other function. So we're going to do the derivative using this product rule with the exact same question, so we should get the same answer, right? Like, the derivative should not change, okay? But we're going to see how you could use the product rule to do it instead of our old way. Okay, so let's call, so this one here would be our first function g, and this one would be our second function h. So if I want to find f prime of x, first I could take the derivative of g, which what did we say the derivative of this one was? What's the derivative of this guy? Just 2. Then I need to multiply it by the original of the other function. So x squared minus 2x plus 1. And then we do plus, and then we do the opposite. So now we'll take the derivative of h, which we said was 2x minus 2, and then multiply by the original g, the original of the other. And this may not look like the exact same answer yet, but we can simplify it down. So this will be 2x squared minus 4x plus 2. This will be 4x squared minus 4x minus 6x plus 6. Combine like terms, and we get 6x squared negative 14x plus 8. Plus 2. So we did indeed get the same answer, right, as what we did before, okay? So this is how the product rule works, okay? In this case, I mean, you may have thought it was easier to multiply it together first and then take the derivative, right? I mean, you may have liked that version better, and that's okay. You can do it that way. I don't think there's necessarily one of these ways that is faster than the other in this particular case, okay? But you're not going to always just have a polynomial times a polynomial where you can multiply them out. You might have sine of x times cosine of x. And then you're forced to use the product rule, right? Because you can't multiply those together to get something you know the derivative of, right? Or you'll have something like x squared times x, sine of x. I have to use the product rule on this, right? This is two functions multiplied together. Until today, you did not have the tools to find the derivative of this function, right? Like, you did not know how to find that derivative. But now that you know the product rule, you can find that derivative. So let's do that now. So first we'll find the derivative because it says apply the product rule to find the slope of the normal line. Well, the derivative will be the slope of the tangent line, so we'll first start with the derivative. So let's use the product rule. Take the derivative of x squared, and we get 2x. Then multiply that by the other original function, which is sine of x. Then take the derivative of sine of x, which what's the derivative of sine? Just cosine. Derivative of cosine is negative sine. And then times the original other function, x squared. And in this case, there's not really any simplifying to do. So that would be your derivative, right? So this is a time where you would have to use the product rule, okay? Now question, before we move on. Would it have mattered if I had done the derivative of sine first times x squared and then done sine times the derivative of x squared? Would it have mattered which one? No, because it's addition, right? So like if you did it the other way and you flip the order, it wouldn't matter, right? It's addition. So if you want to just do the derivative of one of them, multiply by the other function. Do the derivative of the other one, multiply by the other function. I tend to start with the first one, but sometimes I think I will switch it up if I think one of them looks easier, right? And I'll start with that one, okay? But so it doesn't matter what order, as long as you do the derivative of one times the other, derivative of the other times the other one, okay? So now it said apply the product rule to find the slope of the normal line. The derivative is the slope of the tangent line. So we want to find the slope of the tangent line at x equals pi. So we'll plug in pi here. What is sine of pi when we're on the other side of the unit circle? What's the y value there? 0. So that'll be 2 pi times 0. What's cosine of pi over there? -1 plus -1 times pi squared. So we'll get negative pi squared. Is that the final answer to this question? They want the slope of the normal line. Is that the slope of the normal line? No, that's the slope of the tangent line. But what can you tell me then the slope of the normal line is? Opposite reciprocal. So you'll do change the sign. So positive now, 1 over pi squared. All right, I want you to try using the product rule a little bit on your own. Try these 4. Use the product rule. These are all products to find the derivative. If you're having any confusion about how it works, let me know. On the first one, use the product rule. Don't use the old way, where you practice the new stuff. All right, go ahead and pause and check your first one here. This should be your final answer. This would be the first step. And if you didn't get this answer, maybe double check with someone at your table. And then this one, I'm going to talk about how we should, this one is more than likely you would be expected to simplify it. But for the first step of the derivative, that should be what your first step would look like. So double check those two there. See if there's anything you have questions about. If you don't have part of that, and you're not sure how, talk with your table. Any questions on either of these so far? Okay, let's talk about this second one real quick because I want to talk about if it was a free response question, right? And the only thing I was assessing was could you do the product rule? Like you could leave your answer like this, right? You have done the product rule. Most of the time when they just have a simple equation like this, if they're going to ask it on the AP test, it's going to be a multiple choice question. And you have to recognize the answer, right? And so you probably will be expected to simplify. So I'll go through that. But also, just a side note, this one, when you do the derivative of the square root of x, you can do x to the 1/2, and then you'll have 1/2 x to the negative 1/2, and then you move it down to the bottom. That's a good one to just kind of memorize this form of the, like the square root of x derivative is 1/2 square root of x. Just kind of save your brain some time and energy. That's just a good one to memorize. Okay, so now if we were to simplify this, this is kind of what you would be expected to know. So first let's start with multiplying the first one together. So we'll have x squared minus 3x plus 2 over 2 square root of x. And then I'm going to leave the square root of x times 2x minus 3 alone. And then when I want to add those together, what am I going to have to get since one of them is a fraction? Common denominator, right? So I would have to multiply this fraction over here by 2 square root of x on top and bottom. So I'll have x squared minus 3x plus 2 from the first fraction. All over 2 square root of x. And then here, when I multiply 2 square root of x times square root of x, what will happen to that square root of x? It'll be x. So we'll have 2x times 2x minus 3, which this will just become 4x squared minus 6x if we distribute. So first, if you do 2x times square root of x, you'll get 2x. Then if we distribute that, we'll get 4x squared minus 6x. Combine like terms, and we'll have 5x squared minus 9x plus 2 all over 2 squared of x. So that is probably what you would have to recognize how to turn that answer into. Does that make sense? I know that's all algebra, but we had one kind of like that on the last test for the unit where you had to kind of take the derivative and then put it into a nice form, right? It's also going to help us in the future when we start analyzing derivatives. To be able to have a derivative in a full fraction will help us analyze it, specifically where it's equal to 0 or where it does not exist, like where the denominator equals 0. Okay, so that will be one of the reasons why you also want it in that form. Any questions about how we got there? Okay, so now let's talk about the next two. So this one here, f prime of x, we'll have the derivative of x cubed would be 3x squared times sine of x plus the derivative of sine is what? Cosine x. But let's make sure that we show clearly that this is multiplied by x cubed, right? You cannot multiply this x and this x together, right? You can't put stuff inside cosine. So make sure you show that that's cosine of x times x cubed. There's not really any simplifying you can do there. For this one over here, to find the derivative, we'll do the derivative of 3x plus 2 is 3 times cosine of x. Derivative of cosine is what? What's the derivative of cosine? Negative sine times 3x plus 2. You might see that one written that way and just left that way, or you might see them distribute the negative sign, so you could see this as 3 cosine x minus 3x sine x minus 2 sine x. You could potentially see that way just because they distributed the negative sign out. Any questions about any of those? Okay, I want you to try these two. These two have a little bit more, they don't seem that bad, but they have, well, the first one has a little, try the first one on the next page. It has some potential to confuse young calculus minds. Remember, theta is just a variable, so treat it like it's an x and try to take the derivative of that function. All right, for this first one, first question. This first thing, 3 theta, is that a product? Is that a product?
No.
It's not? Is it two things multiplied together? Isn't that 3 times theta? So it's a product, but do you have to use the product rule on that? No, right? Did you use the product rule on 3x to find the derivative? No, what's the derivative of 3x? Derivative of 3x is just 3, right? So what's the derivative of 3 theta? Just 3. Now, you could use the product rule on that, but eventually you're going to take the derivative of 3, which is 0, and everything will, the other half of the product rule will go away, okay? So we don't when it's a constant, okay? When it's a constant in front. Let me show you another example of something like that that is going to be important for you one day here soon. If I have the derivative of 3x squared, do you use the product rule on that? No, what's the derivative of that? 6x, right? You take the derivative of this, right? The derivative of x squared is 2x, and then you multiply by the 3. That was something we called the constant multiple rule. We didn't call it, I didn't say it out loud a ton, right? But it was one of the properties of derivatives. So if it's a constant times a function, there's no need to use the product rule. You can, and it will work, but it's a lot of work because you end up with a constant. Derivative of a constant will be 0, so the second half of the product rule will always just disappear, okay? So whenever you have a constant times a function, don't use the product rule, just use the constant multiple rule, okay? But is this a product? Yeah, that's theta times sine of theta, so do I have to use the product rule on that? Yes, so the derivative of this will be, I'll do the derivative of theta first. What will be the derivative of theta? Just 1. Remember, think about it as x times sine plus derivative of sine is cosine times theta. Not really much simplifying to do there, okay? H of x, this one's slightly interesting for one particular reason. So if I take the derivative here, I can do the derivative of sine, which is cosine of x, times cosine of x, plus the derivative of cosine is negative sine times sine of x, And so that I'll end up with cosine squared minus sine squared. Which, what does that equal? No, that one's actually not equal to 1. I tricked you. It has to be what to be equal to 1? Plus. It has to be plus, right? But it looks similar to that. So there could be a case where they ask you to use that identity. We will use that identity a lot in calculus. Cosine squared plus sine squared is equal to 1. You could have a multiple choice question where they you remember that trig identity part of pre-cal that you guys love so much, right? Yeah. Okay. You could be asked to turn this into an equation that only has cosine squared, cosine in it, not sine. Like it might be a multiple choice question. So in that case, if we have cosine squared x plus sine squared x equals 1, we could say that sine squared x is equal to 1 minus cosine squared x, right? And I could replace this with 1 minus cosine squared x. And then simplify that down to -1 plus 2 cosine squared x, because it'll be positive cosine when you distribute that negative. So you could potentially be forced to use one of those identities to turn it all into cosines, or recognize that that's the same. Okay? Not very often, but you could. Any questions about that one? All right, so product rule, not too bad, right? Pretty easy, pretty nice, pretty convenient, okay? But we do need to be able to use it in a lot of different contexts. Specifically, a lot of the time it's not just going to be a function times a function where you actually have the equation, right? It's going to be more abstract situations where we have graphs, we have tables, we have just the names of functions and facts about them, right? So for example, here we have p of x is f times g of x, and r of x is x squared times g of x. So if I ask you to find the derivative of p, you're going to have to use the product rule. If I ask you to find the derivative of r, you're going to have to use the product rule, right? Because they're both products. But it's not like you have the equation for f and g. So we have graphs of f and g, and we have some facts here. So first it says if g prime of -4 is 2, what is the value of p prime of -4? So first we're going to find p prime of x, and then once we do that, second here. First, we're going to find the value of p prime of x, and then we'll find p prime of -4. So p of x is f times g. So to find the derivative of p, we got to use the product rule. So that'll be f prime of x times g of x plus g prime of x times f of x. Yeah? Just from the product rule. So then to find p prime of -4, we'll plug in -4 for x. So we'll need f prime at -4, g at -4, g prime at -4, and f at -4. They already give us one of those values. What's one of the values they already give us? G prime of -4 is 2. How do I find f of -4? How do I find f of -4? The graph, we have the graph of f, right? So look on your graph of f. At x equals -4, f is -1. Same thing with g of -4, right? Just plug -4 into the graph of g. That is 6. Right, so they gave us this one. We just plugged those values into the functions because we had the graph. But did they give us the graph of f prime? Can we plug -4 into a graph to find f prime of -4? How am I going to find f prime of -4? They didn't give that to me. Like they gave me g prime. Yeah, what is the slope? What is the derivative on a graph? What is the derivative on a graph? I gave it away a little bit. The what? Slope of the tangent line, right? So if I want to look at the derivative at -4, that's pretty nice that it's linear, right? Because the slope of the tangent line is just going to be the slope, right? And what's the slope of that line right there? -1. See how it's up 1 over 1? So f prime of -4 is -1. And so this will be -6 minus 2 or -8. Now, this says find the equation of the tangent line to the graph of P when x is equal to -4. Well, you guys did one of the hard things already. What are the 2 things you need to find the equation of a tangent line? What 2 things? Point and slope. Which one did you already find? You already found the slope of the tangent line, right? Because it wants the equation of the tangent line to P, and this P prime of -4, that is the slope of the tangent line at -4, right? So this is the slope of the tangent line already. So I just need a point. I already know the x value is -4. But which function do I plug -4 into to find the point? There's f, there's g, and there's p, and r, but r probably is not going to be involved. Which one of those functions are you going to plug -4 into to find your point? P, because we want the tangent line to the graph of P, right? So we want to draw that tangent line at -4, so we want to plug -4 into P. P of -4 will be f of -4 times g of -4. We already found those values. That was 6 and -1. So that'll be -6 will be our point. So then we can write our equation. Y plus 6 equals -8, x plus 4. I know some of you have asked, you should not box your answers on the AP test free response questions because sometimes it will only grade what's in the box. That's what you're telling them. And so if you have good work and then you did bad work in the box, then you're shot. I just do it sometimes to call out your attention to the final answer. But you should not box your final answer or your answer on the AP test. If you don't want them to grade something, cross it off. Okay. I'm going to give you the answer for this one. If we have time, you can come back and try it on your own. But I'm not sure we're going to have time. So g prime of -2, if you want to try this on your own, is 2. You also have plenty on the homework as well, so don't feel like you have to. And then r of -2 is -12. So then your equation of your tangent line is y plus 12 equals 20 times x plus 2. Okay, so let's try some other questions together with tables this time. This first one says, estimate the value of the derivative at 3.5. How should I estimate the value of the derivative at 3.5? Should I look at the derivative at 4 and 3 and just pick a number between those two? No, I don't want to do that. I could do a lot of things in between there, right? Now, maybe if you only had one answer on a multiple choice and that was between those values, then maybe you have a chance. But there's a lot of numbers between -4 and 2, right? Okay, and the rate of change can change really fast, okay? So how do I estimate a derivative? What do? We had this on last test. How do I estimate a derivative? Yeah, pick 2 points around it and find the average rate of change, right? Because if you want to approximate an instantaneous rate of change, pick 2 points around it, find the slope for the average rate of change nearby, and that'll be a decent approximation. So If we want to approximate the derivative at 3.5, what two x values should we use for our points? 3 and 4. 3.5 is right in between there. So we're going to do the change in y, f of 4 minus f of 3 to find the y change in y for the slope, and then 4 minus 3 to find the change in x for the slope, or the average rate of change between 4 and 3. From the table, f of 4 is 1, f of 3 is negative 2, 4 minus 3 is 1, so we get 2. So the derivative is approximately, oh yeah, 3. 3? Yeah? 3, sorry. 3, 3, 3, my bad. No, go away. Okay, so that had nothing to do with the product rule. Just good review. Now, for this question here, q of x, we want to find the derivative of q at 4. Is this a product right here? Yes, that's 2 times f of x. But do I need to use the product rule on that? No, because that's a scalar or a constant times a function, right? And the constant multiple rule that we talked about, right? You don't do the product rule on 3x, right? You just say the derivative is 3, right? You don't do the product rule on 3x squared. So when it's a constant, just take the derivative of that and then multiply by the constant, right? You don't have to use the product rule. You could, it's just way too time consuming and pointless. So the derivative of that will be just 2 times f prime of x, because you take the derivative of the function and then multiply that by the constant. You guys have been doing that already without even realizing it. So then write down what you think the rest of that should be. Minus 4 times g prime of x. And we want q prime at 4. So we'll have 2 times f prime at 4 minus 4 times g prime at 4. By the table, that's 2 times 2 minus 4 times negative 3, or 16. Are we all okay with what I mean by not using the product rule here for these guys? Any questions about that? Like why this derivative is just 2 f prime of x? It's just a constant times derivative. Is that okay? Okay, so I'm going to give you a tip to start this next one, and then I'm going to have you try some of these guys on your own. But a tip to start this one right here, okay? This is technically a product of 3 things, right? If you have a product of 3 things, you could start the product rule and then use it multiple times. It could happen, right? So you pick one function to be your first, and then you'll pick 2 functions together to be your second function. And then you'll end up having to do the product rule again when you go to do the derivative of that second function. So I could say, do that here, but I don't have to because this is just a constant. So it's best to just pick like your first function. Think of it as negative 2 times f of x, right? That'll be your first function in the product. And then your second function will be g of x. So now go ahead and write down what you think p prime of x is. First find p prime of x, then you can plug in 3. So first find p prime of x, write down what you think that is using the product rule. Think of those 2 functions as your function. just take the derivative of. So which one do you want to take the derivative of? That one? So the derivative of that part will be what? -2 times f prime of x. Does that make sense? Because the -2 is a constant, so you basically just get to ignore that. Take the derivative of f and then multiply by -2. So just right here, all you need to do is change that to -2 f prime of x. Right here, you can leave that. Because you started saying this was the derivative, right? So now that is the derivative of that first function, that, and then you multiply by g, which is the start of the product rule, right? Yeah. So then put plus, and now flip it, right? Do the derivative of g, and then multiply by -2 f of x. Wait, so you're saying this is not what you think it is?
I think it's possible.
Yeah, you're probably right.
X.
Oh, I'm sorry, I took the derivative of this again. Wait. 2x is that times that. And then x squared plus 2.
2x minus.
Yep.
So there's no way for
Yeah, I think you're probably correct. Yeah. Yes. What was number 2?
yeah.
I'll go back and check it and fix it later. All right, check your answer with this one with your table. See what you got for this one with your table.
Oh,
Your final answer should be -16. If you got -16 for this one, your final answer is correct. For the derivative here, if I do the derivative of this one first, the derivative of -2 f of x, that'll be -2 f prime of x, right? Because that's a constant multiple, so just take the derivative of f prime and then multiply by -2 times the original function g plus g prime, take the derivative of the second function, times the original function, -2 f of x, okay? And then if you go to find p prime at 3, you should just be using your table values, right? So you'll have -2 f prime at 3 is -4. G at 3 is G at 3 is -3. G prime at 3 is 2. And then you have -2 times f at 3, and f at 3 is -2. So then this should be -24 plus 8, which is -16. Any questions about that one? All right, let's do this next one kind of together if you haven't already tried it. So they want us to find the equation of the tangent line. So what's the first thing that I need to find? I need to find the slope of the tangent line. To find the slope of the tangent line, I need to find the derivative, right? So we need to find v prime of -1 to find the slope of the tangent line. That'll be the slope of the tangent line. So let's first find v prime of x. Write down what you think that will be. This is a product again. It's x cubed times f of x, so you got to use the product rule. What? All right, so for v prime of x, right, if we do the derivative of x cubed first, that'll be 3x squared times the original function f of x. Then we do the derivative of f times the original function x cubed. So then when we find v prime at -1, every single x has to be evaluated. Make sure when you're doing this, here's a common mistake people make on free response questions with incorrect equal signs. Remember how I've talked about wrong equal signs before? Do not plug in -1 for any of those x's until you plug in -1 for every single x. Right? Don't plug in -1 for this x and not here for this x. Right? So I recommend finding v prime of x first and then plugging in -1 for every single x. So you'll have 3 times -1 squared times f of -1 plus f prime of -1 times -1 cubed, which is 5. And then you'll find your y value by plugging -1 into v. And you'll get -2. And then you'll put that into your tangent line. And if you did try the last problem, you should get, for k prime of 3, you should get -46. For anyone that tried the last problem. There's lots of practice like this on the homework, so don't fret if you're still confused. Use your homework to help you. Yeah, what's up?